Welcome to another video episode on my Arduino Yun first generation, which is Arduino with embedded Linux, attached to network and attached to USB storage. Last time I managed to get all info from the previous time to get nicely shown in graphs in Octave, mathematical software. I also managed to get the data from the fototransistor through by means of this flashlight, which I have to position in a certain way in order to make it work. Which is not easy, by the way, but something like this. And by means of this probe here, I can see on the oscilloscope that there is some that it kind of works again. Like I said, it's not really easy to do. Then I have to pay attention to some of this, because this LED doesn't really work, although it's not necessary for the input that I get from the board, input to data. What I need to do is adjust the algorithm to get data directly copied to the computer. Is that wise? I don't know. I want to try it. And another thing is in Octave that I want to get the graphs bigger, because right now it's not really nice to watch. You see 16 graphs. But it's very hard to get to see what's actually in there. So with that, let me log in. I forgot to do that. So then of course I have to set the date, and I will show you later how I have done that. Although if you have seen this video before, the series before, then you know how I do it. My current date is 22 and time is 9:26. Invalid date. Why is it invalid date? Yes, that is why it is invalid date. I made a typo. Now it is correct. I have to remove the data log, the old one, then activate the monitor. The monitor has to be activated in order to give data and to get this motor running. At least that's the idea. Giving data and seeing that nothing works. Well, nothing is not entirely correct, but oh, it works. It just needed some assistance. Anyway, that is how it works. Now, and I realize this introduction is kind of boring, so I also see that this LED is burning. And I see that this one is burning now. So that's all good. Does it mean that this can flash? Not really. Okay. Does this one flash? Yes, this one does flash. This one doesn't. So I need to charge better. Anyway, that's it for this introduction with electronics and Arduino. Let's go to the software side. Alright, then Let me just come a bit. So here is one part, there's the other one, there's the Arduino, and of course the electronics, and right now I have already to put some data in it. Another thing is what I pointed out, the graphs. Let me use the old data that I already have and run it with the software that I wrote. So I am reading data log, and I should actually add command read data log from disk. First column. Oh yeah. First column, second column. Is that correct? First column is AXS file disk. Yeah, I think that is all correct by now. Second column for time. Time. This and this means time for the 1000. So to refresh memory, these pop meters can be set in a few settings, and 4 of them give, that means a threshold of 500 gives a value. So over 500, under 500. So then I get 1000, 1001, and for the other 1002 and 1003. Those are the thresholds. So that is what happens here with 1000 time, 1001 time, 1002 time and 1003 time. Putting them in graphs and display. And this is why I want to enlarge it. Can I? Well, in this figure I can't. Not all of them. I want to view them like from here to here, etc. I am not able to do that. Because when I enlarge it, I enlarge only the window, not the graphs. Zooming in is not enlarging. Because then I get something stupid like this. This is not what I want. Okay, won't I zoom in? Probably. How do I want to zoom in? Okay. But this is not funny, this is not nice. I want it large, big, so I need to work on that one. And this is old stuff, because this is now containing new stuff. Oh, this is not the intention. So and you can see a lot of zeros that are in there. So every time and again I need to remove it. Oh, of course, this is how I set the date. It is Linux, so date -S for set, and then date and time. And this is the American notation. In Netherlands we say 22/01/2019. So if you're trying and you don't know that you get a lot of errors. Anyway, let's be here. Remove and go. But there are again errors. No, not errors, zeros. Why are there zeros? Still a good question. Well, yeah, there are zeros because it is now on. I didn't manipulate the pot meters yet. So 1001 and 1002 are missing, which are here. So you will always have zeros. You cannot have both settings at the same time. Then end of this, it is sending to the data file to datalog.txt. And how do I copy? From here to the computer. Anyway, let's first see for Octave. How do I change the situation? Well, some searching reveals that within Octave, and I assume within other programs such as Octave as well, I cannot enlarge the graphs. I can enlarge font, I can enlarge number of things, but not the graphs. And you can set the size if you're going to print, but I'm not going to print. And if you have, as you have seen, zoom in and zoom out are not the way to go. So the only solution is reduce the number of subplots and increase the number of figures, because this is figure 1. Then I would end up with 4 figures. And then the question is, will that be this size and 4 larger figures? Let's hope so. So, oh wait, of course I need to quit this one. Then I have this figure that I still have to work out. And why is this happening? I have no clue. Okay, and process, that's good. And back to editor then. So here I am starting figure 1 with 4 subplots. 1, 2, 3, 4. Then I need to have here figure 2. And figure 2 belongs for now to this one. So this is going to be figure, let's say 5. Going back here, figure 1. Again, 4 figures, 4 plots in the figure. This will be figure 2. Then this will be, oh wait, I have to change something. Because now I have in one plot 2 rows, 2 columns. Not 4 by 4, 2 by 2. Big difference. And this is as well. It's not nice in oh wait, and I have to do something else as well, because this is starting figure 2, so this needs to be 1, 2, 3 and 4, and after 4 comes figure 3 and 2, 2 and 1 again. And it won't be the way I like. This needs to be 2, obviously. Then this is going to be 3. Because what I like is everything in one figure. And it looks like that is not going to work out. So this will be figure 4. One. And this needs careful attention. Right, and this is 4. And here we have figure 5. So let's now plot and see whatever happens. That is a lot better. But where are the other plots? Nope, that's not the one I want. This one. Okay. So forward, 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 forward. Oh, okay, let's quit. Figure, figure. Figure and figure. Right. So here we have everything centered around 1001, 1000, 1002 and 1003. Now you can't enlarge the one, you have to do things to enlarge them all. And in this case, less is more. But you can also see that this is, has changed. But I have to dive into this one later. So, the figures are now kind of normal. Readable at least. Alright, that's one thing. Now for the code. The C code. Now for disappointment. I have tried to figure out if I can do two things. First, as you can see here, I do write things into the data file, which is this data file. It is attached right here. Right here on the Yun, in the USB slot. So that's no problem. It's therefore it's considered local data. Now in then C, call it NCC as ANSI space C, standard C, whatever, Kernighan-Ritchie C. It is possible to determine the size of a file, and you can easily do that. Let me use this one, using simply the command size of, and then here size of file. This is standard C, NCC. However, in the Arduino implementation, no such thing. And during my search for now, I already discovered and was reminded, not discovered, reminded, that this particular Arduino Yun is a retired product. No more development. Then, in my, so that's a closed direction. I can't determine the size. I can determine the size in an alternative way, but that's not where I want to go. I want it in here. Automation, one file, one direction, not going to work. In here. The other thing, disappointing, is copying data. If you watch my other video on the fischertechnik controller, TXT controller, I am using the SCP command. And yes, that is not C at all, that is Python. So in Python I can use SCP, etc. But in here, how do I do that? I have found no option to do that in C as well. Can I do it? I can't imagine it can. No, I can't imagine it can't be done. However, considering the file I/O stuff that I have found, I haven't found anything that says yes you can, and that's a bummer, because now I still have to open, and let me just do that, a new window. So this being on the laptop, but actually this is on the Yun. This is on the Yun. This is not. This is the laptop, and I have to do it like this. This. To copy the data, and this is exactly the way they show in the forums. So no automation the way I like it, which brings my idea to a grinding halt. Do I accept that? Well, there's one thing I haven't searched for yet, and that is giving system commands via C. I know it is possible, but this is possible in Arduino C, in AVR C. So let me have a look for that. And of course, I come to a nice solution, but it has a catch. First, the solution is which I come across by searching run shell command, not tested yet by the way, which says then SCP etc. MT data log text user and directory, and this is then the internal IP address. Should work, but there's a catch. This is a problem because they said data log data 1, yes, that's the array I'm using, then 4 elements, 4 columns, no, 7 columns, 4 rows. That is what is being done. And then it starts all over again. But if you look here, of course, there are a lot of them. So this is 1 through 4 and 7. So you have only this. So you need a lot more. Not this one, bad example. You need this. And that a lot of times. So basically, this is the wrong location or the right location, but you say here data file close and then write data. So basically you need to find out how much of that stuff you want. Introducing a new variable. Then say how many times do you want it. Divided by 4. So let's see. I have here the size is, well, it will be now a lot larger. Yes, almost twice as large. 15. Because this is going on as well. How much do you want? 1000k or 1k? 1000. Actually 1024. And then divided by 4. And divided by 2 is 512 is 1024. No, that's rubbish. Anyway, that's the amount of lines that you want to count. And after that count has been done, copy. That's what you want. Then it is automated. So let's see. Count lines. Oops, that goes wrong because you need to set the count of lines. For line is 0. A line smaller than how many times? 4,000. 1,000 lines. Alright, then I go here and after that you say alright, do it. Data file close, print it. That could be the solution. But I'm getting out of time for now, so that is for next time. And this could be the solution I was looking for automated copying. Does it work? No clue. For now, save. And this also save. and then I have to test it all. And then I don't have to use this anymore. I can start Octave, run it, and just go ahead. And I guess that's it. And I have to wrap up due to time. So for now, not really fiddling with the electronics, but more with the acquired data and trying to get a more interactive, no, less interactive script. For now, thanks for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up. Sorry for the lengthy introduction and recap. Sometimes it's needed. Please give a comment or a suggestion. You can also follow me via Instagram and Twitter. Please donate to keep videos coming to you, as well as Instagram and etc. You can also become a patron and have your name mentioned on my website, and depending on the pledge, also with my videos. Have a nice day. Thanks and bye bye.